All right, this is AP, AB, and BC Calculus. We're doing Unit 8, Section 12. For my AB students, this is your very last video of AP, AB Calculus. For my BC students, there is one more unit video in Unit 8. There's 8:13, which is for BC only, and then Units 9 and 10 are all BC. So again, congratulations, AB students, you've made it. This is your last video this year. So we're going to do volume with the washer method the same way we did in section 11, but this time we're going to revolve around other axes, not always the x or y axis. So again, we're going to have to pay a little bit more attention to that other bound, right? When we do top minus bottom or left minus right, one of those quantities has always been 0 when we're using an axis, and now we're not going to be. All right, so the region bound by these curves, and we're going to use a calculator on all of these for the integration because, again, it'll be fairly tedious. Some of them you can do by hand, but we're not going to here just because that's a skill that we've practiced in other videos and you could apply here if you needed to. So this region that we can see in the picture is bound by the parabola, which is clearly the frown here, and the line is rotated about the line y equals 4. So this is where y equals 4 is, right? This is my axis of rotation. That's what I'm rotating around. To create a solid, we're going to set up an integral expression and then find the volume using our calculator. So I pick a random slice somewhere in the middle here, right? That's my slice, and I rotate it around to see that I get an annulus. There's an inside circle, there's an outside circle, right? And that's not very circular, but such is life. So my outer radius is from the axis of rotation down to the line. That means my big radius is going to be the top, which is the axis of rotation, minus the bottom value, which is the line. I'm just going to leave it that way. There's no reason to clean it up. You don't even have to make it a 4 plus 2x. It's great. If you were doing this by hand, I suppose you would clean it up, but we're not going to do it by hand. We're just setting up the integrand and using our calculator. The smaller radius, right, little r, is going to be the top, which in this case is 4, minus the curvy part, right, which in parentheses will be a 3 minus x squared. There are my two radii, right? I need the bounds, but you can see that the bounds are readily available in this problem. You're not second calcing to find them. You have a -1 and you have a 3. So my volume is going to be pi, integral from the smaller x to the larger x, right? From the first washer to the last washer, of big R squared, which is going to be 4 minus a -2x, quantity squared, minus little r squared, which is going to be a 4 minus, in parentheses, 3 minus x squared, quantity squared with respect to x. If it's me, and you don't have to do this, but if it's me, I'm going to go ahead and make this thing my y1 and this thing my y2, right? So I'm going to, this is from the last video, so we'll clear all that out. All right, so I'm going to make my first one 3 minus x squared into my y1. I'm going to make -2x into my y2, right? And then what I do when I quit out of that is I'm going to go ahead and do my pi, right, math 9. And then I have a pretty complicated integrand, right? So this is what I'm showing the AP. So down here, I'm going to put stuff that is for your brain only, right? So down here in the highlighter, what I'm putting in my integrand is 4 minus y2 quantity squared minus 4 minus y1 quantity squared. That's what goes in here. So this is what you put in your calculator, but the AP is giving you no credit for this. So this is not for the AP folks. That gets you nothing. You have to show this. This is probably worth 2 to 3 points of credit, just this, right? And then from that, you get an approximate answer, but you have to know how to put it in your calculator. So I'm going to put parentheses, 4 minus vars over to y vars. I want function, and I want the second one, quantity squared, right? Minus 4 minus vars over to y vars function y1, close the parentheses, quantity squared. I double check that that's what I mean, right? 4 minus the second function, whole quantity squared, minus a 4 minus the first function, whole quantity squared, comma, with respect to x, from, and then I know that the bounds are x is -1 to x is 3, so -1 to 3. Again, this is one that is mathematically possible by hand, but is pretty disgusting, and you're not likely to have to do it by hand. What's going to happen is this is either going to be on a calculator section, or they're going to say set up but don't integrate this answer. Or it'll be multiple choice where the choices are all integrals and you don't actually have to find the value. All right, let's go ahead and try P1. Same two curves, how convenient. Except this time, we're rotating down here around y equals -7. So same curves, but I'm rotating this way. So if we look at what that's going to do, right, I take a random slice somewhere in the middle, and when I rotate around, I'm going to get this annulus. And again, I get that I'm not the person we should ever count on to draw things. It's fine. Okay, so my big radius right, is going to be from this outer curve, which is clearly the frown, right, the parabola. So my big radius is going to be the outer curve, f of x. Oh, and actually, I didn't do a thing I could have done here. I could have been smarter here, and instead of written this, I could have called it g of x, and instead of writing this, I could have called this f of x. So if I had been slightly smarter here, the lazy way to do this that would have been completely mathematically acceptable would have been 4 minus g of x and 4 minus f of x, and that would have been smarter. So this would have been better. I should have done this. I didn't think of it, and I apologize. So let's go back to the second one. So I'm going to go ahead and say the top curve, which is f of x, minus the negative 7, right? And if you want to make it plus 7, that's fine. The inner radius, which we'll use purple for the inner radius here. The inner radius is this chunk right here. That's going to be the line, which we know is g of x, minus the axis of rotation, which is negative 7, right? And if you want to make those plus 7, please have fun. That's great. I don't care. It's up to you. So again, we're going from negative 1 to 3. It's the same bounds. We can see that it's the same exact graph from the last example, just a different axis of rotation. So my volume is going to be pi, the integral from negative 1 to 3, of my big radius squared. So that's going to be f of x minus a negative 7 quantity squared, minus my little radius squared, which is g of x minus a negative 7 quantity squared with respect to x, and then type, and I get an answer. If you think that I'm lying about this minus a negative 7 thing, look at some of the AP solutions guide for this kind of problem. I'm not kidding you. This is what they're looking for in the integrand. They're looking for exactly what the expression would be without any simplification. So it's fine to call it f of x and g of x if they're f of x and g of x, that's fine. It's fine to leave it as minus a negative 7 instead of writing it as a plus 7. The less math you can do, the better. Now, I look at this and I say, okay, cool. I could kind of take my own work from the last problem and just second enter and then change the inside stuff in the parentheses. So notice that I called this one y1 and this one y2. So when I put this stuff in my calculator, I just need to make sure that I do that correctly. So I'm going to hit second enter. I'm going to keep the pi. So instead of a 4 minus y2 here, this is a y1 minus a negative 7. Again, if you want to make it a y1 plus a 7, fine. I don't care. So I go to vars. I go over to y-vars. I pick y1, right? Minus a negative, and then I'm going to second insert the 7, right? I'm not going to take any chances. I'm just going to leave it as minus a negative 7. Here, I'm going to go to vars, over to y-vars function, and pick y2, minus, and then I'm going to put in a negative, and then second insert the 7, right? Everything else should stay exactly the same, and I go ahead and hit enter, and I get that this is approximately 442.336. Okay, and that's what the AP needs to see from me. They need to see this set up with all of the bounds, the constant, and all of the stuff in, in the integrand correct, and then they need to see the answer. All right, so now this one's in terms of y, but again, we've seen this before, especially when we're given the graph, it's not a big deal, right? So now we're going to revolve around the line x equals 6. Well, that's here, right? So I'm taking a tiny little slice, and I'm making this like really thin, this thin ring. Right? This is a really thin annulus. There's not much width to it. So my outer radius is going to be from the axis of rotation to the curvy piece, right? So this is the curvy piece, right? So my notice here they're not called f and g, so I have to gut it out and write the entire thing. So and my axis of rotation was 6, right? So my bigger radius is going to be the 6, which is on the right, minus in parentheses the y squared plus 1. You should just leave it that way. My inner radius, right, from here to here, is going to be the 6 minus the line in its entirety. You see how you need parentheses there. Don't distribute, don't change it, it's fine. Now, I didn't yet take the opportunity to go ahead and put these in my y equals. Remember, when you put them in y equals, you're using x instead of y. So I'm going to use 2x plus 1 as the first one because I always enter them in the order that I see them in the problem, right? And I'm going to use x squared plus 1 as the second one, right? So when I quit out of this, right, so I can already see the bounds, right? I kind of messed it up a little bit because I write all over things, so I apologize. But we can see that this one is definitely at 2, and this one is definitely at 0. So my volume is going to be pi times the integral from 0 to 2 of my big R squared, which is going to be 6 minus, in parentheses, y squared plus 1, close those and square the whole thing, minus the small r squared, which is 6 minus this set of parentheses, right? Quantity squared with respect to y. You need this setup. This is probably worth 2 to 3 points, right? And that's really, really important. But then you just need to be able to type it in your calculator. So conveniently, I already have stuff in my calculator, and actually, this one looks an awful lot like the one I used 2 entries ago, right? If you look, it's 4 minus y2 up here, and here it's going to be 6 minus the thing I called y2, so I'm actually going to hit second enter twice. because I see that the laziest option here is to just change these 4s to 6s and then change my bounds. Because this is 6, right? So 6 minus the thing I called y2, that checks out, minus, this will be a 6 minus the thing I called y1, so that checks out. And then my bounds, instead of being a -1 to 3, are, I believe, a 0 to 2. And then I delete a parenthesis, right? And that looks like that should be it. So I get that this is approximately 28.483 or 4, depending on if you round or truncate, and you also need that, right? Cool. Moving on. Okay, so same exact set of equations, right? I still have my y1 and my y2, but this time I'm rotating a different direction. So this time we're going to rotate around where x is -1. So I'm going to take this little slice here, and I'm going to rotate around. There's the inside of the ring, and there's the outside of the ring, right? And I kind of missed, but you get the idea. So here, my big radius is going to be the line minus the axis of rotation. So my big radius is the line, which is the 2y plus 1, minus the -1, because that's the axis of rotation. My little radius is going to be the curvy piece, which is this guy, right? The y squared plus 1 minus a -1. I already know the bounds, right? The bounds are still from 0 to 2 because that's the first washer to the last washer. So my volume is going to be pi, the integral from 0 to 2 of my big R squared, which is going to be 2y plus 1 minus a -1 quantity squared minus my little r squared, which is y squared plus 1 minus a -1 quantity squared with respect to y. You don't have to clean that up. If you want to, you can, but again, you run the risk of doing something silly. So I look at this and I realize that if I go back to where I had the y's minus a -7, it seems to me that that's almost exactly what I just did. So I'm going to hit second enter, and look, all I need to do is change this from y1 minus a -7 to y1 minus a -1, right? Because this is definitely my y1. This is minus a -1, right? So I change those -7s to -1. And I'm going to make this a 0 to 2. Now, it is worth noting that on a real, sorry, that's not an X, on a real AP, you're not conveniently going to have a problem just like the one you just did right above you in the calculator, but in this video, it makes way more sense than re-entering everything from scratch. So I hit enter, and I get this is approximately a 30.159, and that's what I need for my AP, right? If you're able to do this in your head, right? If you're able to, in your head, picture what the R values are, that's great. Congratulations. They really are only giving you credit for these things, for the integrand with the correct bounds, the correct constant, and the correct stuff on the inside, and for the correct answer. So if you're able to do that, dope, congratulations. I will say that picking the wrong expressions for R is usually what goes wrong. So please make sure you get comfortable with the skill. All right, so we're going to do the quick ones that require a calculator. And then, obviously we've been using a calculator anyway, but these are physically going to require a calculator. So here, what makes this hard is you're going to have to find the bounds, right? So let's go ahead and go to my y equals. We'll clear out some of this stuff. So we have a 0.6x times, in parentheses, e to the x plus a 1, close the parentheses, right? That looks right. And plus a 3, my bad, at the very end of the whole thing. And then this one is a 5 minus a 2.3 x squared. Cool. Double check everything's right. So we're going to go ahead and zoom 6 because I don't know what to expect right now, so we'll see what we're looking at. Okay, so this is our graph, and we're rotating around the line y equals 1. So if you were just going to do a rough sketch of this, here's what's happening. Like I have this graph, and somewhere below it is y equals 1, right? So this is the line where y is 1. That's the thing I'm rotating around. So what's happening is that this shape, right? This shape right here is rotating this way. Again, you don't have to be awesome at sketching these graphs, but you do have to have enough of an idea that you can sketch the graph without it being a big issue. So it seems to me that my big radius is the parabola, because that's definitely the parabola. So this guy, right? My big radius is this guy, g of x, minus the axis of rotation. My little radius is the e to the x thing, right? So my little radius is the e to the x thing, which is the f of x, minus the axis of rotation. All I need now are the bounds. I know that they start here and end here. I just need to find those values. So my volume is going to be pi times the integral from a to b of my big R squared, so that's going to be g of x minus 1 quantity squared, minus f of x minus 1 quantity squared with respect to x, and then I get an answer. All I have to do is find a and b, and then I'm done, right? I have to write them down somewhere. I can't just jump to the answer. I have to clearly indicate what a and b are as values. So I'm going to go ahead and find a. I'm going to go ahead and find B, and then I'm going to use them, right? So second calc intersect, right, which is going to be 5. I go to the first one, meaning the one farthest left, and I get that this is approximately a negative 1.121341, I quit out, and then I have to store that as alpha A, right? If you forget to store it as alpha A, then you have to go back and do the step again, which, you know, is a natural consequence to forgetting to do a thing. So second calc intersect, all about the natural consequences, right? So, and I get that B is approximately 0.629888624, right? I quit out, and then I store as alpha B, right? And now I'm going to go ahead and type this integral in. Notice that this is going to be the thing I called y2 minus a 1, and this is going to be y1 minus a 1. So you can either second enter a bunch of times if you want, because you've probably done this recently, but I'm going to go ahead and redo it. So I get math 9. I want the thing I called y2 minus a 1 in parentheses. So I put a parenthesis, I go to var's function y2 minus a 1, that entire quantity together with the radius, so I square it. Then I do the same thing again with y1. So I open a parenthesis, I go to var's over to var's function y1 minus 1, close the parenthesis and square it, because that entire expression was my radius, comma, with respect to x, comma, alpha A, comma, alpha B, right? And then I hit enter. And I get that it's approximately a 41.771, right? So this is what the AP needs to see. If the bounds are something, if the bounds are some number that is an approximate value, you need to write what those bounds are, and you need to write them with as much detail as your calculator allows you to. All right, let's try it again. Oh, hey, that's the same one, but rotated about a different line. I thought I did something clever. All right, there we go. So same one, different line. So we already know what this graph looks like, right? So we can go back to the graph for a sec. Here's the nice thing. I can be a little bit lazy here. I'm not going to reinvent the wheel because I used the same graph. Okay, so it's this graph. We already know that this is the point A. We already know that this is the point B, right? And we know that if we look at where these axes fall, right? So the axes are like somewhere like here, right? That y equals 7 is up here. It doesn't have to be exact. It really doesn't matter. You're just trying to get the image of what this looks like. So when you rotate this thing around above it, right? Now your axis of rotation is going to change, right? So your so now that your axis of rotation is up here, your radius, the big radius is top minus bottom. Your big radius is going to be the axis of rotation minus the e to the x curve, because that's not the quadratic. So hang on. Big radius is the 7 minus the e to the x curve, which is the f of x, right? Your little radius, we didn't use green yet. Your little radius is going to be the axis of rotation down to the parabola. So your little radius is 7 minus g of x. And you already know a and b, right? So I'm going to be a little bit lazy, and I'm going to drag them from the last video because I'm just not, I don't really feel like having to rewrite them, if I'm being perfectly honest. Hang on. Yeah, so I'm going to be a little bit lazy and drag them from the last video. We already have them stored in the calculator. I just was too lazy to rewrite them is the honest answer, and I have way too many screenshots on my calculator. Okay, so there's my A. There's my B. All right. Way too many screenshots on my computer is what I meant, not my calculator, but it's exhausting. Okay, I'm going to give myself a little bit of a break that my B got cut off in the screenshot. Obviously, you would write all the digits if you were doing this on a test or on an AP, right? Okay, so there's my A and my B. I'm being a little bit lazy. So I know that the volume is going to be pi, the integral from A to B, right? And then my big R is the 7 minus f of x. So I'm going to get 7 minus f of x, quantity squared, minus 7 minus g of x, quantity squared, with respect to x. And then my job is just to type it in. So if I quit out of this, I can actually second enter and make my life pretty easy because it's the same A and B and everything else. So now I just need to make sure this is 7 minus f of x. So that's going to be a 7 minus, I used f of x as y1. So I'm going to go to var's over to var's function y1. I need to change this to a 7 minus g of x, which will be var's over to var's function y2. The x is the same, the a and the b are the same, everything's good. I hit enter and I get that this is a 52.108 or 9, depending if you round or truncate. So again, this is the information that you would need. It was made slightly easier by the fact that I intentionally picked the same problem, right? I did that on purpose so we wouldn't have to, reinvent the wheel. Okay, so you'll see the same thing's going to happen here. I'm going to use the same two curves in E4 and P4. I'm just going to pick a different axis of rotation. So again, what's tricky about this is that when you're putting it in your calculator, it's going to be flipped, and that's kind of obnoxious. It's going to be backwards. So basically, when I graph this, let's go ahead and graph in terms of x. And again, if you're using something like Desmos, you can graph in terms of y, and that's totally doable. It's just that realistically, you're not using Desmos in the middle of an AP Calc exam. If it's in school, in person, that's just not a thing. So, so since that's not an option, certainly you can use Desmos on something like homework to figure things out, but it's helpful to understand how to do this in a TI calculator in case. All right, so these are my graphs, but again, remember everything that I have here is an x is actually a y, right? I double check that everything's right, and then I graph them, right? So this is what it looks like, right? So again, if you're trying to ever picture what this looks like, so I'm going to just show you whenever we do these, I'm going to go ahead and graph that y equals x just to show you what this would look like if you were trying to figure out what it actually looks like on a graph. So here's the idea, right? This is what the, and let's zoom square because it's easier to see if I zoom square. Okay, so this is what the graph looks like on the calculator, right? And you can see that because the calculator's in the correct direction here. If I wanted to see what this looks like when I actually do it in terms of y, right, what I'm doing is I'm flipping this thing horizontally, like left and right, and then I'm going to rotate it until those black lines line up, right, as close as I can. It's not perfect, but that's the idea. So this is what the graph actually looks like. So what you're seeing here, right, this is what it looks like in your calculator, right, this is what it looks like in your calc, but this is what it should actually look like. So if that helps you imagine this a little bit, and then we're rotating about the line x is a -2, right? So this is the line that we're rotating about. So that kind of helps you see the imagery because this is the window that we're talking about rotating, right? What we're going to be doing then is we're going to be taking this little slice, right? And it's going to rotate this way. You can see that, so this is what's actually happening, but you can see that if you pictured it this way, if you pictured rotating around y is a -2 the same way, it would still work. You can get the same concept, right? So this is what you're seeing on your calculator, but this is really what's happening. So it's the same concept, and it'll work out just fine either way, however you're picturing it. So what I want you to notice is that the wider parabola, right? This one's the wide one, right? This is the wide one that's a frown, right? So that's this one. So the outer line is that wide parabola to the axis of rotation. So my big radius is the wide parabola, right, which is this -0.2 y squared minus y plus 3, minus the axis of rotation, which is minus a -2, which is not pretty, but it is what it is. My smaller radius, right, is the smaller curve, like this curve right here, right, the smaller curve, to the axis of rotation. So my little radius is the 1.9 y squared plus y. Oh, what I mean by smaller was more narrow, right? And also you'll notice that that's the one that's a smile, right? This one's a smile, right? It's more narrow comparatively, and it's a smile. So this thing minus the axis of rotation, right? Once I know that, now I just need to find the bounds, right? So I'm going to have to find those bounds. So when I second calc intersect, right? So second calc intersect, and I always start to the left first, so I'm going to find this one first. I'm going to get that the first point of intersection, right? So the first point of intersection, which is actually a y value despite being an x value on my calculator, is -1.762786, right? Dot, dot, dot. And I'm going to get to the second one, so let's quit out of that and do x and store that as alpha a, because remember, natural consequence, if you don't, is that you have to go back and do it again. So second calc intersect, I'm going to scroll to this other point of intersection. And remember, that big black line there is just to show you how we would reflect to see what this graph actually looks like. It's not part of the graph. It's just to show you what happens when we're doing things in terms of x instead of y. So I'm going to quit out of this, right? I'm going to hit x again, and then I'm going to store that as alpha b. Okay, so now that I know that, I just need to set up my integrand properly, right? So my volume is going to be pi times the integral from a to b, right? And then this, I probably didn't give myself enough space, but we'll try to make it happen. My big R squared, which is going to be the -0.2 y squared minus y plus 3 minus a -2, quantity squared, minus my little r, which is going to be 1.9 y squared plus y minus a -2, quantity squared, with respect to y. And sometimes this happens on an AP and you're like, hey, I'm squeezing that dy in, please don't take away credit, right? It is what it is. I definitely squeezed it in. Try to make sure you have more room on the AP, but I'm just going to let it go because it's been a long day. So, so then I'm going to integrate, right? I'm going to go to second pi, right? I'm going to math 9. And then what I want to put in is the thing, so keep in mind that this was the thing I called y2, right? This was my y2 minus a -2, and this was the thing I called y1 minus a -2. Again, this is for me only. So this is for me and for you, making sure we put things in the calculator right. It is not something we tell the AP. So I go to vars over to y vars function y2, right? minus a negative 2, close the parentheses and square it, minus, in parentheses, vars over to y vars function y1, minus a negative 2, close the parentheses and square it, comma, with respect to x from alpha a to alpha b, close the parentheses, and there's my answer. So I get approximately 148.904 or 5, depending on if you round or truncate, right? And again, this kind of messy, ridiculous thing, I need to have the a's and the b's. I need to have this entire integrand, including the dy that kind of got cut off, right? Make sure that's visible on your actual AP, and then I need to have the answer. That's what they need to see. Everything else is sort of for your own benefit. Now, the only good news about the last of these, oh, hey, I accidentally did the P4 problem before the E4 problem. Sorry, people, we'll go ahead and go back and do this. My bad, when I skipped ahead and showed you I did P4 first. Okay, so let's go back and do E4. So we've already set up this graph, right? We already know, we already know that this is what we're seeing in the calculator, but that this, right, we know that this is what we're seeing in the calculator, but this is what's actually happening, right? This time, though, we're revolving around the line x equals 5. Well, x equals 5 is going to be here. It's going to be on the other side of this thing, right? So, or if you think about it this way, on this graph, it would be y equals 5, right? So that's my axis of rotation. So what's happening is I'm taking this little spot here, right? And I'm rotating this thing this way to create that annulus, right? So my big radius is going to be the smile, the narrow smile, minus the, up to the axis of rotation. So my big radius is going to be the axis of rotation, which is the 5, because that's farther to the right, minus the bigger smile, which is the 1.9 y squared plus y, right? My little radius, which we'll do in purple, right, inside here, this is the big wide frown, right? My little radius is going to be 5 minus that big wide frown graph, right? I already know A and B because I accidentally found them in P4, so we'll just go steal them from P4. Sorry that I did that backwards. So I guess treat E4 as P4 because oops. All right, so there's my A and B, which I cheated and already found in a previous problem, so we're just going to stick with that. Or sort of a previous problem, kind of. All right, so I know that my volume is pi times the integral from a to b of big R squared, so it's going to be 5 minus the 1.9 y squared plus y quantity whole thing squared, right, minus 5 minus the negative 0.2 y squared minus y plus 3, close that parenthesis, close the whole thing, quantity squared with respect to y, and then I just have to find my answer. So notice that this is what I called y1 and this is what I called y2. So I'm going to go ahead and hit second enter, right? And instead of doing y2 minus the negative 2, I'm going to do 5 minus vars over to y vars function pick y1, and then I'm going to delete that extra value. And then here I'm going to do 5 minus vars over to y values function pick y2, delete that value, still same in A and B as it was in P4, and I get that this is a 113.37304. So I'm hoping that you're getting from this that this is really the same skill over and over and over again, and that the hardest part is figuring out what your radius is. And if we're talking area of cross sections, like we did in the first couple videos, then the hardest part is figuring out the area of the cross section, but that's really the hardest part of the problem. It's not so much the volume. All right, so let's do that same challenge problem we've seen before. We're going to take this graph, right, and I'm actually going to shrink it a little and move it so that you can see what would happen. So we're going to move this down a little bit. We're going to take this graph, and I'm going to rotate it around y equals 9, right? So that means that here's 9, right? So what's happening is this is my axis of rotation. This entire thing, right, this thing is going to rotate, and again, we should never let me draw anything, but it's going to make a ring, okay? The trick is that there's two sections, just like we've seen when we did this thing before. There's also rings that are created in sort of the K section. And again, excuse my inability to draw. It looks like a child's drawing things. It's fine. So we're going to treat this as two separate problems. We're going to treat this as the H section of the graph, right? And we're going to treat this as the K section of the graph because there are two things happening here, right? So in the H section of the graph, I noticed that my big radius would be the axis of rotation minus the outside curve. Well, the cool thing about that is my big radius is just a 9 minus 0, right? That's it. So it's just straight up a 9. My little radius, right? My little radius is going to be this curve to the axis of rotation. So my little radius is going to be 9 minus the curvy piece, which is the negative x squared plus 6x. Notice the whole thing's in parentheses. So that means that the volume of this piece, right, just this piece, would be pi times the integral from 0 to 3, because that's the h piece of this thing, right, of my big R squared, which is 9 squared, and you should totally leave it as 9 squared, minus, in parentheses, 9 minus parentheses negative x squared plus 6x, close those sets of parentheses, squared dx. That's this half, right? That's that half. If I do the same thing for the blue half, my big radius is going to be top minus bottom. So again, that's a 9. My big radius is also a 9. My little radius is going to be from this axis of rotation to the inside curve, which is the line, right? So my little radius is going to be 9 minus, in parentheses, negative 3x plus 18. So that means the volume of this piece, right? The volume of this piece is going to be pi times the integral from 3 to 6 of a 9 squared minus, in parentheses, 9 minus parentheses negative 3x plus 18. Close that parentheses, close the other one, square it, and then squeeze in a dx somewhere, right? Kind of ran out of room. So my final answer is going to be those two things together. So my answer is going to be that the total volume, right, because this was the h section, this was the k section, is going to be pi, the integral from 0 to 3, of 9 squared minus 9 minus negative x squared plus 6x. Is it plus or minus? I think I made it minus here by accident. That's a plus. It's a plus. So plus 6x, close the whole thing, square it, dx, plus pi times the integral from 3 to 6 of 9 squared minus 9 minus, in parentheses, negative 3x plus 18, close the parentheses, close it again, square it, dx. So two separate integrals, right? That's why it says using one or more integrals, and I think that it might say find the volume. Oh, use your calculator to find the volume. That's no fun at all. Okay, so if I was going to use my calculator to find the volume, because it says that I'm supposed to, I see that there are basically two curves I have to worry about here, the negative x squared plus 6x and the negative 3x plus 18. I don't really have to worry about the 9 because I feel like it's easier to just type the number 9 in. So I'm going to go ahead and make the negative x squared plus 6x the first curve, and I'm going to go ahead and make the negative 3x plus 18 the second, right? When I quit out of this, I'm going to get two integrals. I'm going to get pi, math 9, right? And then inside there, I'm going to have a 9 squared minus, in parentheses, 9 minus vars over to y vars function y1. Close that, square it, because that's my other radius squared, comma, with respect to x from 0 to 3. Close that, that's the first one. Second, pi again for the second integral, right? Math 9. You could factor out that pi and put it in front of both, but then you'd need another set of parentheses, and I just wasn't about that lifestyle at the moment. So 9 squared minus, in parentheses, 9 minus the thing I called y2, so vars over to y vars function y2. Close that and square it, because that itself was the second radius, comma, with respect to x from 3 to, I believe it was 6. And then hit enter, and we get this ridiculous, completely crazy number. So we get that this is a 1,1,9,6,6,3, or 4, depending on if you round or truncate. And that's your challenge problem. All right, so that is the last problem in our AB curriculum. Congratulations, you've made it to AP Review.